Hello, today we're going to talk about deriving certain equations. Alright, the equations we'll be deriving are the slope-intercept form. So y equals mx plus b. Alright, what we are deriving here is when you have the slope-intercept form, you're really looking for two things. You're looking for the m, which is your slope. Now there's two ways to find slope. All right, if you have a graph, you can use rise over run. All right, with a graph, you can also use the slope formula, which is y2 minus y1 over x2 minus x1. This is when you have 2 points, or 2 ordered pairs. When you have 2 ordered pairs, an XY type thing, so 5, 6, all right, 5, 6, and 2, 3. You can plug those into this equation and find the slope. It's whatever you want to do, really. I like using rise over run if I have a graph and I need to do it quickly. If I have 2 given points, if I'm just giving points, I can do this. If I'm given 2 points, I can always just graph them and then look at my rise over run after that. It's whatever you prefer, do whatever you want. The other thing here is, your B here is your y-intercept. There's no way to derive that through a formula or anything. If you have a graph, you just look at where the line you're graphing goes through the y-axis. And that point right there is the y-intercept. You can also derive it if you have the slope, you find the slope and you plug one of these points in and then solve for b's the other way. Alright, so an example would be if I had y equals 13 over 8x minus 8. My slope is always my number in front of the x, and my y-intercept is always this back number. Written as an ordered pair, it's 0, negative 8. Written alone, it's negative 8. All right, here's our first actual problem when deriving certain equations. So we've already derived it, but what we want to do here now is graph it. All right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 8, 9, 10. Send it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So what's our slope? Is negative 3, 8. It's the number in front. Our y-intercept is 5 or 0, 5. All right. So the first thing you always do when you graph it is you start from your y-intercept. This is always your starting point. So I go to 5, 0, 5. So 0 on the x and 5 up. All right, now I use my slope. Here I'm going to use rise over run. All right, and it's negative. So you have 2 types of lines usually that you're going to have here. Negative and a positive. So since this is a negative slope, my line is going to look like this when I'm finished graphing it. Always keep that in mind when you're doing it. So then I go rise, so I'm going to go down 3, 1, 2, 3. Now I have to run. Which way do I have to run? East or west to make the line look like this? Well, I have to run to the east, 8. And then I connect the dots. And there you go. That is how you graph a line from the slope-intercept form using rise over run and your y-intercept. Now we're going to go the other. All right, now I have an example here. All right, I have a graph. I need to plug in some points, so I'm going to plug in the point 2, 6, then 1, 0, and all right, now we're gonna find the slope here. All right, we wanna know the slope and the y-intercept. Once we find that, we can derive our equation. So a new way that I've been doing this year, and it shows you on the lesson if you look at it, is I make a triangle. So to find the slope on here, the easiest way to do it is rise over run, right? Rise over run is basically just making a right triangle. So I'm going to start here, and I'm just going to keep going down through the line until I get to where this point is. Once I get to where this point is, directly across, then I go over to meet it. Now, granted, mine aren't the straightest things in the world, but I have created a right triangle. All right? Now, all I have to do is tell you what this leg is and this leg. So how many is this leg? Well, it's 2. It went over 2 times. 1, 2. How long is this leg? It's 8. So you do rise over run, which is 8 over 2, which is 4. Because it's also a positive line. All right? Well, what about if I did the other 2 points? I know you're asking yourself. If I did this point and this point, well, I run over 1, now I'm even with that point, and then I just go down to meet it, create another right triangle. How many is this? 1. How many is this? 4. So then I have a rise of 4 over 1, which is 4. So these are what are called similar triangles. It doesn't matter which points you take. The slope will always be the same as long as it's a linear equation. So I have my slope now, which is 4. My y-intercept is where this black line crosses the red one at -1. So now I just add all that in to my slope-intercept form. And that is the equation of this line. All right, and here is the last one. We're going to find the slope-intercept form. So we need to find the slope and the y-intercept. We're going to use rise over run. All right, so let's start with this point. Let's make a triangle. So I'm going to come from here, and I'm going to go down until I meet that point. Once I meet that point, meet them together, and make a right triangle. So how many is this over? 6. How many is that up? 6. So it's 6 over 6, which is 1. All right, that's my rise over my run. Let's try it from the second point just to show. Run over and meet this one. Then I'll run down and meet it. And I get 6 over 6, which is 6 over 6, which is 1. So my slope is 1. My y-intercept is where it crosses at -3. So my formula, so my thing is My slope-intercept form is that. All right, this has been Derived Certain Equations. Hope it helped. Good luck.